Good evening to all. My name is Karthik, son of Ganesan. My metric number is 241311022. Today I am here to present about our PBL titled Light Intensity Controller. We are consist of 5 members: Samsul Akmal bin Suzaini, Ahmad Irham bin Akmarul Azhar, Anif Firhan bin Azif Fahmi, Muhammad Izzat bin Muhammad Radzi, Karthik Analaki Ganesan. Firstly, I want to talk about the introduction. Controlling the brightness of lighting systems is a fundamental aspect of modern electronics, especially in applications such as home automation, energy efficiency, and ambient lighting. Pulse width modulation (PWM) techniques have some a preferred solution due to their efficiency and precision. This project titled Light Intensity Controller utilizes the widely known 555 timer integrated circuit configured in stable mode to generate a PWM signal. The circuit includes a power MOSFET that acts as a switch. This mini project demonstrates a practical and cost-effective way to control light intensity electronically, make it suitable for learning DIY application and future enhancements in lighting systems. The next one is objective. The main objective of this project is to design and develop a light intensity controller using a 555 timer IC and pulse width modulation technique. These systems allows users to adjust the brightness of an LED or LED strip efficiently and smoothly without significant power loss.
Hi and Assalamualaikum. My name is Hanif Firhan bin Azif Fahmi, and I will be listing all the electronic equipments that we use in this project. So the equipment is in the project is breadboard, transistor, LED, two types of resistor, which is 2 kilo ohm, and a singleton potentiometer. And the next one, we use jumper wire, 12 volt of battery, diode, capacitor, and a plastic spring clip battery holder for the 12 volt battery. So this is our electrical circuit diagram for our project. We use the electric circuit drawing in the internet website to produce the circuit of ours. So for our procedure, after we completed all the gearing of our equipments that necessary for our project, so proceed to our first step, which is design circuit. So we connect the potentiometer and the resistor to pin 6, 7 and 2 of the IC. Next, we connect the capacitor between pin 1, the ground, and pin 2. Then we connect pin 3, which is the output, to the gate of MOSFET. Lastly, the drain of the MOSFET goes to the negative terminal of the LED strip, and the source is connected to the ground. And then for phase 3, we assemble the breadboard. So we place the 555 timer IC on the center of the breadboard. Then we connect all the equipments and wires according to the circuit diagram. Then we ensure the proper orientation for the diode and the MOSFET. Lastly, we use the jumper wires to make all the necessary connections. The next phase is connect the power. So we connect the 12 volt of DC supply to the circuit. Then we verify which is the positive terminal goes to VCC, which is pin 8 for the 555 IC, and the negative to the ground pin 1. Then the next phase is the adjust and test. So we turn the potentiometer knob to verify the resistance. Then we observe the brightness of the LED or the LED strip according to the PWM duty cycle. So we use the multimeter or oscilloscope if available to check the PWM output at pin 3. Then the next phase, lastly, we troubleshooting. If the LED does not turn on, we check for the loose connection on reverse MOSFET pins. Then ensure all the MOSFET is equipped to handle the current required by the LEDs too.
Assalamualaikum and hi, my name is Muhammad Izzat bin Maravi, and now I'm gonna explain about calculation for this project. First is for 555 timer output frequency, we use R1 1 kilo ohm, R2 2 kilo ohm, and for the capacitor 100 NF. So for the F, we got 2.88 kilohertz. Next, for the duty cycle calculation, we got the answer 60%. And then for the calculation, LED current calculation, we assume as supply voltage VCC as 12 volt, and forward voltage of LED 2 volt, and resistor 470 ohm. And then we got the current is 21.3 milliampere. And then the last one is MOSFET power dissipation. We got the power 9.1, 9.7 microwatt. So this is our circuit after assemble of all the equipment, and now we're gonna show how our project work.
So we have completed our light intensity controller project successfully. Now we will show the complete circuit of our project. So if we rotate the potentiometer and clockwise, the LED will be more bright. As you can see right now, the LED shine a bright yellow color. So if we turn the potentiometer to anti-clockwise, the light will be dimmer. I will repeat it again. As you can see, the LED is more bright from the previous one. So this is the maximum of our potentiometer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shamsul Akmal bin Suzaini. So I want to explain about this question. The light intensity controller project successfully demonstrate how a 555 timer IC can be used to generate a pulse width modulated PWM signal for controlling the brightness of an LED. The key feature of this design is the ability to adjust the duty cycle of the output signal by turning a potentiometer. As the duty cycle increases more on time, the LED receive more power and become brighter. The MOSFET acts as a fast electronic switch that responds to the PWM signal from the 555 timer, turning the LED on and off rapidly at a rate not visible to the human eye. This project not only demonstrates practical knowledge of PWM control, but also help in understanding key concepts such as timing circuits, MOSFET switching, and analog digital interfacing.
Okay, now we can go right to the final part, which is the conclusion. The project that we have done has achieved its main objective of controlling the brightness of an LED or LED strip through pulse width modulation. The use of a MOSFET allows the circuit to handle higher current loads safely, making it suitable for practical lighting applications. This project demonstrates a cost-effective and energy-efficient solution for light dimming with potential application in home automation, decorative lighting, and portable electronic devices. Overall, the light intensity controller is a successful example of how basic electronics components can be combined to create a functional and useful system.